Okay, this time the microphone is working. So this might be a slightly quicker version. I apologize to any of you who tuned in and saw that I was just flapping these lips for no real reason. Thank you to those who pointed that out. Okay, something I forgot to mention for the domain and range of logs. Okay, I'm going to click on this sort of link here. Showcase. Oops. That's why you keep the stream overlay open so you can actually figure that information out. Okay. I've got 2 to the x here, and then which is an exponential function. I said that logs are the inverse of exponentials. Inverse graphs are reflected over the line y equals x. Let me turn on projector mode for this. What that means is you take all your xy coordinates, flip them around. It also ends up being sort of a mirror image over this graph, okay? I can look at a sort of a few coordinate points here. It looks like we have 1, 0. So on 2 to the x, we should expect 0, 1, which makes sense. 2 to the 0, properties of exponents, always going to come out 1. See things like, can we get to 4? Yeah, 4 you can see is giving us 2. If I were to go to 2 on 2 to the x, we'd expect to see 4. If I can get there. Yeah, you can see we're close enough. Okay. The big piece I want you to take away here are domain and range of these. The domain for 2 to the x, and really any exponential, the domain is going to be all of the x values I can put into my function. What that means is if I go all the way left on this graph or all the way right, do I get a y value? Yeah. The domain for this 2 to the x is all real numbers. Now, the range is what are all the y values that I can get out. Desmos is going to start to do some rounding here, but what this is doing is it's asymptotic. It's getting closer and closer and closer to 0, but it's never going to hit it. So its range, we notice that all of these numbers are positive. It has to get closer to 0 without ever hitting it. What's the range of that 2 to the x graph? It's all numbers greater than 0. So y is greater than 0. Yeah, I could change the base here, right? I could change this 2 to, I don't know, 4. Why not? Come down here and change this guy. We'll notice those pieces all change, but it's still clearly a reflection. Domain and range for this thing didn't change. For a logarithm, and this is going to be true for all logs, right? I could program this in the previous iteration of the video I did. To be any base you want, it's not going to change the domain and range for these. The domain and range for any exponential are all real numbers for domain, all positives for range. That's going to flip for a logarithm. The input, all of the x values I can put into this graph are now all positives, which used to be the old range. The range for this guy is all real numbers. It's going all the way negative, right? If I drag this sort of point here, you can see before it goes away, yeah, it's kind of cutting off here. It's thinking I'm getting too close to 0, and it keeps going down, right? There's no limit to that, and as it goes further to the right, the y value is going to keep going up. So here's the takeaway. I'm doing this with 2 to the x, but it doesn't really matter what the base is. It's still going to be true. The domain for any exponential is all real numbers. Its range is greater than 0. I've got sort of a rough sketch of this here. Actually, I should shift this. There we go. That's a little better. Doesn't matter what this base is. Okay, it's just going to basically change how fast it grows. Cool. Log base 2 is the inverse because those bases match. If this is a 17, then it's a log base 17. Great. Do you notice how let's change that. Let's keep it. The old domain becomes the range. That's because x parts become y. The old range becomes basically the new x part. It's because y's become x's. So what does this really mean? Okay, we're not going to ask you to graph things. Since my domain is greater than 0 for logs, that means I cannot do log of 0. I cannot put a negative into any log. It doesn't matter what base it is, whatever you want right here. I can't change that. And log of -4, right? If I can't put a 0, I also can't put negatives because this is saying all positives. That's the big thing. If you get to a point where you have a logarithm and you're trying to like put some number in it to clean it up, like we give you log base 4 of 0, you got to pause and be like, hold on, that doesn't exist. Undefined. Stop right there. Log base 4 of -4, 4 to what power gives you -4? It doesn't happen. We know that they get fractional, they never go negative. I see a question about sort of office hours. Yeah, office hours still today at 2. It's just the way that you access it's going to be a little bit different. I'm going to have to kind of change where that information is posted because apparently enabling the waiting room and then me allowing you in isn't secure enough. So I got to just find a way to post some of that stuff on the classroom. When I have that information, I'll share it out with everybody. But yep, times are going to stay the same. Just the way you access office hours is going to be a little bit different. Thank you for that. Be ready for that quiz tomorrow. And I don't know if you're a snow person, I guess get outside and enjoy it. I don't know, build a snowman, make a hill. If you build a snowman, send me a picture. Be curious to see how you're doing sort of your quarantine. Practice social distancing with snowmen. I don't know. Everybody have a good day.